Hello,
Dr. King.
Hello.
Hello.
Dr. King also, and Lázaro, or Jan. Jan is also with us. Hello, Jan. Okay, Lion, we start with Forth from Malaysia for first time. This is very interesting. Are you ready, Lion?
Yeah, I'm ready, yes.
Okay. Go ahead.
Okay, I think I'll just make a quick introduction about myself. Yeah, just checking the sound. Is it clear? Everyone can hear me? All right?
Yes,
Okay,
yes,
good.
fine.
Yes.
All good.
All right,
You're fine.
Thank you. Yeah, so all right, just a bit of I'm almost 50 years old, so I was born in early 1970s, and I graduated from United Kingdom, UK, University of Southampton. I got my PhD in 1999. That is like 21 years ago. In the image processing. Now, I'm actually maybe slightly different from you all because I'm not really a low-level hardware programmer myself, because most of my career I have been involved in AI, artificial intelligence, high-level programming. But eventually, I discovered Forth, and and I thought that there's lots of software engineering techniques in Forth that is actually very useful for non-Forth programmer. So that will be the topic of my presentation today, which I actually made a short video, and I think Peter will play the video, and I'll answer your questions after the video. Thank you.
Perfect.
Peter? I think he's trying to play the video, is he?
Is the video, can you see it?
Yes. Sound is a bit quiet. Not getting any sound though, Peter.
When you share a video, you have to share the sound also. Is the sound being shared?
Doesn't matter much. There's subtitles.
Yeah, we can follow the subtitles. You could also share the link in the chat if anyone wanted to watch it directly.
There's something gobbled coming through, but one cannot make out what it is.
Peter, can you paste the link to the YouTube, to the Google Drive directly into the chat. That way people can open it up locally.
But that way everybody will have to start at the same time.
I think it'd be more for looking at later, perhaps, if we don't.
Can I just ask an obvious question? Because I somehow missed the beginning of the video. Who is in the video?
In the YouTube video,
Yeah,
I think it's Dijkstra, isn't it?
Mr. Dijkstra.
yeah, that's what I thought it was. Okay,
Yeah.
just wanted to confirm that.
If I don't have it wrong, Dijkstra was one of the, or his work was sort of the kernel that started Linux. One of his students was Linus Torvalds, who started Linux.
I actually used one of his quotes in my Forth documentation, but apparently I was told afterwards that I had misunderstood what the quote meant, but it seemed to be good to me anyway. Yeah, so he's a very famous name.
He's
I think
famous in
Dijkstra
computer
was the guy
science.
who
Yeah.
developed Pascal, wasn't he? So if you spend
No, that's Nicholas Wirth. No, but
yeah,
he's
sorry, you're
involved in functional programming as much as
Yeah.
like, that's probably
And
the
actually,
main-
Dijkstra was Dutch and Linus Torvalds was Finnish, so that's very unlikely that he was a pupil of Dijkstra.
What I do know is Dijkstra developed a multitasking, round-robin multitasking operating system for the 286, because the $10,000 license fee for Unix just became too expensive.
You're thinking of Andrew Tannenbaum, maybe?
Yes, you're right. Yes,
Mhm.
my mistake. Yes, thank you. It's been years since I've read anything
Yes.
of that.
I think, yeah, I think Dijkstra is just a big, much more a
Language guy.
in computer science and languages. Yeah,
Yeah,
particularly
yeah.
functional programming languages and Lisp, that sort of thing.
Yes, that's correct. My mistake. Sorry, guys.
I'm
Oh, I
in
think we should
awe.
all be.
Yeah,
Yeah, we
sorry.
should be. Sorry, keep going.
Okay, I'm in awe of the expertise on tap here. It's incredible.
Mhm.
Yeah, I would like to watch this clip with sound. So, but we'll just go with this.
Yeah, Dijkstra is actually also well known for his shortest path algorithm.
To the front end. Eventually, the same concept has been extended to cover React, Redux, and even HTML.
Okay.
Just as I
Alternative
of this Zoom session,
venster.
just as I was preparing this presentation, the organizer of this Zoom session, Peter Forth, posted a post comparing C with Forth, which I think is a nice introduction to what I'm going to present today. As you may agree, the majority of Forth programmers are what we may call hard Forth or low-level hardware coders. However, in this presentation, I shall demonstrate the meta-programming techniques derived from Forth can be applicable to many high-level programming languages and frameworks. We use the term soft Forth to refer to Forth implementation on top of high-level or the third-generation programming languages. The idea of soft Forth is not new, starting from early implementation on top of C, then Java, as well as JavaScript, Rust, Haskell, Golang, and even Lisp. However, our implementation called ForthScript, spelled PHOSCRIPT, taken from the Greek word meaning light, aims at integrating with the function libraries of the host programming language, instead of implementing the full vocabulary of Forth. As you can see on the bottom of the screen, they are the PHP ForthScript library on the left and JavaScript ForthScript library on the right. They essentially consist of these steps. Firstly, splitting a space delimited string into tokens or words in Forth terminology. Secondly, pushing non-function word or token onto the stack, or executing the function in the host programming language by calling call user func in PHP at line 1272 on the screen, or eval in JavaScript in line 595. Note that we have introduced a colon suffix for function words that are mapped directly to the host programming language. Due to time constraint, we shall not delve into colon definition words or aliases, branches, conditions, and other more complex code structure. The code samples are available on our GitHub account, which is given together with the notes of this presentation. So the first demo program for ForthScript is an AJAX script, which sends a simple addition script from the browser front end to the PHP backend, where the PHP backend calculates the sum and returns the result to the front end. Eventually, the same concept has been extended to cover React, Redux, and even HTML, which I suspect no one has attempted to convert into reverse Polish notation. Here is a simple demo on how ForthScript reverse Polish notation generates HTML code. At the bottom of the screen is a Linux terminal where the ForthScript commands are entered as PHP command line arguments. The script simply produces a one-cell table comprising the word Jack. The HTML output is shown at the bottom of the screen. Three.js is a popular 3D animation library for WebGL. We have modified the original demo to include an additional tank body following the original, as well as an additional target. We then created two function words, tank colon and target colon. A JavaScript statement, m equals to new Forth, open bracket, closing bracket, creates an object m so that we can access the internal functions of Forth. The function word tank colon is used to create one additional tank body following the existing chain of bodies. Jitsi Meet is a video conferencing app like Zoom, but fully open source. Its source code from GitHub can produce a web app, Android app, as well as iOS app. The red text CVST colon, cube underscore CVST colon, and so on in the browser console on the left of the screen are ForthScript words which maps to WebGL canvas and Three.js functions. What you are seeing here on the right hand side where the cursor is that at the back here is actually a darkened video stream, all right, where it has been processed using the TensorFlow body mix algorithm. As you can see, there is a human figure here, and it is trying to detect the human figure and showing the result with a white silhouette, and it darkens the background. And then it has also a chat box area where we can actually use the message box here to enter forth script command, and we can actually output the forth script output here within the chat box. So as you can see, it's actually fairly sophisticated. After seeing what forth script can do with JavaScript and other mobile and web frameworks, we shall briefly discuss Firefox Fire 4X, a project to put forth into the Firefox browser. As you may know, WebAssembly is a major project in browser technology, which in my not so humble opinion, is simply Lisp in your browser. In 2018, I attempted to put Jones Forth into Firefox, hence Firefox. Eventually, I decided I should put my energy into educating younger programmers concerning using Forth in high-level programming first. Then I shall let them decide if they want to pursue Firefox, which I believe may bridge the soft Forth and the hard Forth worlds. SimEngine, in our opinion, is a modern attempt on computer algebra that began with SimPy, a project based on Python, which marked a departure from the traditional Lisp-based computer algebra systems. We have forked SimEngine and named it as SimForth. As shown at line 313 in the video, C++ allows us to define a stack of reference-counted pointers, or RCP, a generic data structure that is used to represent algebraic terms. Here, we have an example of expanding x plus 5 to the power of 5, entered through the command line in reverse Polish notation at the bottom of the screen, which yields 5xy power 4 plus 10x squared y cubed, and so on, as shown above the reverse Polish notation at the bottom. Our next example is a fork of an underappreciated project called BTOSG by GitHub user Miguel et al. That combines the bullet physics simulation engine with OpenSceneGraph. There have not been many attempts at combining physics simulation and scene graph at C++ level. Perhaps it is more convenient done at a higher level, such as Python, as demonstrated by PyBullet, a Python project utilizing the Bullet library. In the original code car.cpp, there is only one car falling from the sky. We have added a false word new car colon with some other dummy code to produce an additional 4 cars in the demonstration. The code in the video shows that we use C++ template at the bottom of the screen and function mapping at line 234 to map the false word new car colon to a C++ function sm_new car. Viewers with sharp eyes and mind might have noticed a little note that said inverse of Dijkstra shunting yard algorithm earlier in the presentation, which we did not elaborate, as its significance is only apparent after we have shown examples in various programming languages. As listed on the screen, quite a comprehensive range of languages in our opinion, developed based on the very shunting yard algorithm that Dijkstra himself pioneered. The existence and applications of the shunting yard algorithm and its inverse led us to formalize homoiconism, a body of algorithms and models based on the unique feature of Forth and perhaps a selected few other languages where data and code can be represented in a uniform syntax. As such, I was wondering, Did Dijkstra know of Forth developments, and would he conquer the path I have taken to confront the problems he highlighted at the beginning of this presentation? Having demonstrated that code written in any programming language can be homo-iconified or transformed into a Forth-script function word, it is of course tempting to consider keeping all these homo-iconic functions in a graph database and to serve as a model for artificial intelligence. We wish to propose one last novel idea, that is, by traversing upwards from a node in a tree, we may then extract the key or edge connected to the node concerned. Further, such key or edge is essentially a representation of the relationship of the child node and its parent. The key, edge, or relationship may then be used to trigger one or more homo-iconic functions. The homo-iconic function may then produce the results as one or more nodes in the graph database. Then the cycle of upward traversal repeats itself. If a discussion on human-level artificial intelligence sounds too far-fetched, then Geisha in its reduced form at degree 0 or G0 may have a very practical application. Geisha 0 is practically a universal software management system covering all conceivable programming languages, managed using a graph database, combining the features of Forth and other modern software engineering tools. In our next presentation, we shall demonstrate how Geisha 0 can be used to manage and extend JIT-CMIT together with other image processing libraries such as TensorFlow and OpenCV, with examples in Forth-script code that can look as simple and elegant as the legendary Logo programming language.
Okay, wow.
Anybody has question? Lion, your presentation is finished.
Okay, yeah, I'm here. Yes. Yeah, so yeah, this well, we open for questions or comments from anyone.
Why did you decide to use Forth as opposed to the language that you're like? What's the key advantage, do you think, of Forth based on the fact you're building on top of another language?
Well, you see, over the years, right, I have been, I have been I have done programming like since the Logo or Basic during Apple II, in my teenage. And over the years, I have been learning all the high-level programming language from PHP, JavaScript, and so on. And they got more and more complicated. And people at my age, I find that, most of the people at my age find that these programming language and frameworks are getting more and more complicated. And there don't seem to be a way to simplify them. And in fact, simplifying high-level programming language is a big challenge. And then eventually I discovered Forth, and I realized that it is actually the best, and I don't know any other solution that can, do what Forth do. So that is like magic to me. And I think it has to do with the Dijkstra Chantigny algorithm and the inverse. Now, this is, of course, a very deep and fundamental mathematical theory or theorem, which, I think if people have interest, can spend quite a long time trying to explore. In fact, if you can actually play Dijkstra's own interview video, which I'll give you the link, you discover that he actually mentioned those problems. So that's my quick answer. And in fact, this is actually a very big topic if you want to explore further. Thank you.
Great, thank you.
Okay, guys, Lion will be presenting in December a second part. Is this okay, Lion?
Yeah, I'm okay with that. Yeah, and in fact, you know, I'd like to get your feedback on which part of this meta programming in Forth that you like me to start with, because you know, you can actually look at many different angles from the web programming, or even Linux shell, or even a C++, or even if you are really interested in like creating this Firefox, you know, because that is actually the most interesting project in my opinion, because if you can put if we can put a traditional Forth compiler or interpreter into the browser, we will actually beat the WebAssembly flat. I think that is actually a very exciting prospect, or quite challenging, I would say. Yeah, I'd just like to get your feedback, and I mean, of course, we can communicate. You don't have to tell me now. We can communicate on the Facebook group about, you know, your preference. Yeah, thank you.
Yeah, and would it be possible for you to post in the comments a link to that video? Is it available on the internet for us to watch later?
Yes.
Yeah,
yes.
sure. Yeah.
All videos.
Thanks.
Okay.
Also, just a point of a thought that would be interested in your opinion. But it seems to me most AI is actually very simple arithmetic that needs to be done repeatedly. And I mean, in one way, that there's a sense that you know, GPUs have become very popular for doing these calculations. It's actually because they're really like RISC chips. Yeah, they're really simplified instruction sets that just do calculations. They're meant for video calculations, but it equally reads across to AI calculations as well. And maybe there's something in there that, in terms of language, these higher level languages that get more and more complex and then have all sorts of layers of packages, you know, in between the programmer and them actually doing that arithmetic. You know, maybe this is a role for Forth in drastically simplifying all of that, just getting to those repeated calculations and doing them quickly.
Yeah,
interested in your opinion.
Yeah, about your your comment on the artificial intelligence and low-level operations. I think actually those are not the main problem. In fact, what I wanted to point out in my presentation just now was that you know, the last slide on this thing that I call Geisha. Geisha stands for in fact, Geisha simply stands for graph search and homo-iconic action. It really had only two parts, okay, the graph search and the homo-iconic actions. Now, this is actually, if you like, my lifelong discovery. What I was trying to say is that you are right. I agree with you. All these AI operation are very low-level operation. However, the problem I think that is facing most of the AI people is that they are trying to represent the function in very high-level programming language, okay, which makes it impossible to process, you know, compared to Forth or homo-iconic functions. So really, the first step I have taken is I need to find a way to represent all the very complicated AI function. Okay, as you can see in the last slide, there are TensorFlow, there are OpenCV, and so on. Now, this is just a beginning. But in theory, using reverse police notation, we can actually homo-iconify, you know, if that's the new word that I want to coin, meaning that change all these high-level function into simple Forth words. Now, when we can do that in Forth world, then we don't need to worry about the data structure because everything is actually on the stack. That greatly simplifies the whole problem of AI. Then the second part of the novelty is the graph search. All right, you see, I think a lot of the AI people has gone the wrong direction in the sense that when they do graph search, they start from the top to the bottom and try to find the answer. But if we actually go the other way, that is, we start from the bottom and go upward, we are actually finding out the relationship of every node. Now, that is actually how I think our brain works. You see, for example, when I mention something, right, you immediately make association with something else. Now that association is a reverse or upward traversal of the tree. Now, so really, what I did in that geisha algorithm is to combine these two ideas. All right, homo-iconic function and the upward search. Now, of course, this is the very beginning. In fact, I'm just starting to code that. In fact, like I said, I am actually preparing a tutorial to demonstrate how this is done. So now, you see, the good thing about this is that even if we don't find the answer to AI, that is actually my sort of own pet project. Like, because, you know, nowadays coding are getting so complicated. So I want a way to simplify everything. So you see, I can actually keep all the different projects within one framework, so that I can manage my code easily. So that is some of the things that I'm planning to do with regards to AI. Yeah, thank you.
Cool. All right. Is there any other comments? Can't hear you, Peter. Sorry.
Yeah, somehow we can't hear you, Peter.
Mm.
We see you talking, but can't.
Yeah,
can't
your
hear
mouth's
voice.
moving, but maybe your headphones.
Can anyone hear lip read?
Matthias is not with us, unfortunately. Yeah.
Of course. Whether anyone could lip read a 32 by 64 pixel image, I don't know.
Yeah,
I don't know either.
yeah, it could be you're sharing the video, Peter. That could be the reason. So whatever you did with that video, stop doing that.
Well, I need help. Can you hear?
Yay! Yes.
No? Okay, it's
Yes.
Johan from Cape Town. I'm trying to say hello to Johan. Where are you, Johan?
I'm here. I can
Hello,
hear you.
Ulrich.
Yeah.
Johan, you're the next. Go on.
Okay, just one small correction. I'm not from Cape Town. I wish I was. I'm in the Kalahari Desert up in the Northern Cape province. Can I share my screen?
Yes,
Peter,
please.
can I share my screen?
Go on.
Yes.
It's your presentation.
Okay.
Sorry.
Right.
Thank you, Lion. Lion, we keep talking with Lion on the Forth Cafe later. Lion, thank you very much.
Okay, thank you very much. Thank you.
Go on, Johan, please. Sorry.
Okay. I'm just trying. I've not shared a screen before. Desktop one, share. Now zoom to share your screen. Can you see my screen?
Not yet.
Okay, hang on. Now Zoom was, okay, I'm going to speak without my presentation. It's going to waste too much time now. I need to quit Zoom and restart it to get this active. Very shortly, my first encounter with RPN was when I was about 13 or 14 years old. One of my cousins had a HP 35. And you guys would know that's the first HP calculator that came out. I didn't quite understand it at the time. It was just a funny little device with blinking lights and fascinated me a little bit. Went through school, high school, did with my last year, my final year, 1978. And Scientific American published a special issue on microelectronics in that year. And that really is where my interest in computers started. Next year, I went to university. I would have majored in computer science or applied mathematics, but I dropped out at the end of the year and started working in IT and IMIT, whatever you wish to call it. Now it was basically a computer operator in those days. I got in-house training on COBOL programming after doing a little bit of basic and Fortran at university. And then I started working here where I'm now with a mining company, and they sent me for training as an electronics technician. It's also more or less the time that the IBM PC came out, and work and whatever, I never ran into Forth again. I read about it in magazines, specifically the Byte magazine, but I never worked with Forth. I've known about it all along, and I've been aware of it, and you encounter it every now and then in a magazine or an article or something. And then about 3 years ago, I basically retired, and I started playing with Raspberry Pis and with Arduinos. And that's when I remembered, but what I'm doing here in these small computers would actually, as far as I can remember, be nice to do in Forth. And that is how I ended up with the group that we're all part of, members of. And how I tried Arduino. I didn't have much success. I think I missed something somewhere, but I almost immediately had good results with the Raspberry Pi. I used one of the open source Forths, G-Forth, with a library that was written actually for C for the Raspberry Pi. I published a short video of what I've done, or the results of what I've done, on the group. If you go and search there, you will find it. And at the moment, I'm still battling to work out the use of interrupts. That's my next big step. I have no definite objective in mind, just curiosity. How do these things work? How do they fit together? And it's something to occupy my mind while I'm basically doing nothing. Like I said, I've basically retired a year or two ago. And that is it. I'm sorry I couldn't share my presentation here, but yeah, I found it very easy to work with the Raspberry Pi and G-Forth. It's not overly difficult. It's a matter of learning Forth to a higher degree than what I have been able to do up to now. So yeah, nothing earth-shattering, nothing, no rocket science, no artificial intelligence here. Just plain simple bit banging, turning bits on and off. But it is quite interesting. And that's it, that's my story.
That's great.
Great.
Okay.
I think it's a really good application of Forth, is these kind of small devices like that. I haven't done anything with the Raspberry Pi yet, but it's or some of the small devices that Peter shares occasionally, like, very low powered devices. That is a good application for Forth.
Yeah, a good friend of mine dug himself into PIC programming. He started off with machine language, and at the time I wanted to sort of tell him, but you can do better with C. And he eventually did move to C, but I think I must start poking him and pushing him towards Forth. I think he will find it way easier than anything else. I was absolutely amazed at how easy it was to turn on lights and read switches. And it was not even a very sophisticated program. So yeah, no, it's quite an interesting thing to tackle. It is not a boring subject. Thank you very much.
Thank you.
Thank you, Johan.
Guys, thank you.
Okay, next one is Cornelius Keck. Are you there, Cornelius? Novix 4000 and what I do in Forth is Cornelius.
He's muted at the moment. Are you there, Cornelius?
Yes, I
yes.
am. You should be. You should be.
Can hear you now.
Yep. So let's try the screen sharing thing again. Okay, can you see my screen? You cannot see my screen. Let's try this again. Now, come on.
Is it being prevented by?
Don't know yet. Is it saying something? Not yet. Let's try this. Anything? Not yet. Damn it.
No.
Sorry. Okay, I want to share this in Zoom with, let's try that. One, and the suspense is killing me. Anything happening? Ah, that was about bloody cotton picking time. Pardon my French. Okay, here we go. Dr. Ting, you might know this one because you were instrumental in developing it. A Novix NC 4000 CPU, single board computer, sold, only not that one, sold in the late 80s in Germany. There was an outfit there that marketed these things, and they came out with a single board computer. Let's discuss the, that UV. We'll get to that. Anyway, we have the CPU and a bunch screen share. Come on. We have a bunch of, would you please get back to my pictures? Can you still see my images?
No, not yet.
Could it be because you got two frames on the screen? Have you got?
No, that's me. That's because I'm also running a laptop to pace myself, so that I'm not running away with the presentation.
Okay.
Because it has happened that there is significant lag as far as Zoom itself goes. So we have a CPU, we have a bunch of memory chips, 2K each. We have firmware and EPROM, that's a concern. And at the bottom of the screen, where is it? Underneath the EPROM, yeah, more memory chips.
Mhm.
The reason why I'm messing with this is I'm into old computers, software archaeology, for instance, reviving old stuff. Now this puppy still works. The CPU has a 16-bit wide data bus. No, it doesn't have one, it has 3. 2 of these chips appear on the right. Oops. 2 of these chips up here on the right are constitute a 16-bit wide return stack. The next 2 constitute a 16-bit wide data stack, and the two memory chips at the bottom are 16-bit wide program memory. In other words, this particular CPU has 3 address and 3 data buses on the chip. Beyond that, it has 4,000 gates. It's a marvel in simplicity, no other way to put it. Let me turn off this thing. So that should keep my screen on a little bit longer. Go ahead.
Cornelius, this is a clock of 4 megahertz, or?
I think this thing is 8. And if I remember correctly, it's been, is this thing mask programmed or an FPGA? I forgot, Dr. Ting knows, doesn't matter.
It's a gate array. It's a gate array.
So anyway, it's very simple. It's a very simple system. And as we, all the memory is static because this little puppy, if I remember correctly, it runs at 8 megahertz. At 8 megahertz, your memory timing is aggressive. Dynamic memory in the 80s wasn't fast enough, especially since you had to shift, you have to shunt the address into a typical 4164, 41256 dynamic memory chip, one of the go-to pieces at the time. You had to shunt the address in then 2 pieces as row address and column address. That took too much time. Besides, you would have, it also would have required adding refresh circuitry. So this is all static memory and it runs pretty fast. This thing still works. It took me a little bit to break into it because I forgot that you had to type a letter B so that this thing could measure its initial bit rate. Instruction set is interesting because it's unencoded. The parts and pieces of an instruction, where is my browser? Yeah, that. I thought about that. If we look at the instructions, every instruction is 16-bit because that's what our data bus is wide. And each and every bit of an instruction does something in the CPU. There is no microcode. This is a hard-coded CPU. Whatever you put into an instruction word does things in the CPU. If you take a look here at bit number 5 that is labeled R, that thing is present on most instructions, but not on any kind of jump. Like if the highest bit of an instruction is 0, the rest is an address, you go there. if it's not a jump instruction, then bit 5 is the return bit. You get a return from subroutine as part of every instruction, which means your return of subroutine not being an extra operation executes in 0 CPU cycles. Yeah, this thing still works, but the problem that we have with this are these two chips with a green sticker. They're EPROMs. I found this thing, or yeah, I unearthed this thing last year in my mother's attic in Germany. German attics are nice places. They're very constant temperature due to heavy insulation, and they tend to be very dry. So this thing survived 25 years in storage just fine. In a dark box, so no UV. Unfortunately, EPROMs, like many other things these days, have shelf life. Shelf life of EPROMs is limited, and there are rumors that after 10 years, you start losing bits. That's not good, because this particular, these particular EPROMs, I have yet to find a dump, a hex dump or binary dump of these on the web. So once they go, this thing no longer comes up. So the very first thing that needs to be done to the system, apart from keeping it temperature controlled, humidity controlled, and in the dark, is to replace these two EPROMs with EPROMs of some or something of similar access time, dump the contents, and put the contents somewhere else. Once that's done, replace them, and, well, get this thing working with the replacements. One could, of course, buy an EPROM programmer to do this, but where's the fun in that? When an Arduino can do the same thing, it has TTL level output, TTL level I/O, which is just what these memory chips require. So we build ourselves a little adapter that plugs into Omega 256 and see what happens. While looking for documentation for this chip, I came across, where's my email? That's not it. We want this. I came across a simulator which where the CPU part is reasonably well written. Apparently, Chalmers University, I probably mispronounced that, so sorry about that, in Sweden, they had some folks at the end of the 90s that, amongst others, re-implemented the Forth2020 in an FPGA. So there apparently is a pin description for this thing. And as part of the exercise, they wrote a simulator. So the other goal is to not only resurrect the real hardware and then drive it sparingly, because that's what you do with old timers, only on the weekends. The other is get the simulator working. The simulator is written in Borland C++. The Novix part is very straightforward. C++ as it was at the end of the 90s. Getting that to work on a Raspberry Pi or any other Linux platform is, well, if you can read compiler warnings, it's an absolute no-brainer, no rocket science. The support code is a different animal because it's geared towards Borland C++, ancient, unsupported, and, well, Windows only, and with Windows graphical user interface, which is highly limiting. So the idea is to replace all that with something that you can drive from the command line in any kind of Linux, Unix environment. The other problem with that is the comments are in Swedish, and Google Translate, oh yeah, the comments are in Swedish, variable names are in Swedish, so it's not exactly self-documenting. And Google Translate does not do a very good job with Swedish to English, especially if there are UTF-8 or other non-standard ASCII characters in there. So I've been translating and redocumenting this thing to get that working. You might want to ask, why on earth am I dinking around with this old stuff? The answer is simple. As it was mentioned a couple of minutes ago, modern stuff has gotten rather complicated, rather heavy on software, and it's getting to the point that having to learn yet another third-party package, third-party technology with tons of dependencies included just to get something simple working is a waste of my time, especially since I'm in the later years of my life, and yet another gimmick to get into yet another gimmick to get stuff done gets old. These old pieces of hardware are very rewarding to look into as long as you have something to get them working. And this puppy is a prime target, especially since there are very few of these around. One word of warning.
Cornelius, it
Yes.
seems strange to me that this board eventually was sold in large quantities. I don't think there are so many.
There aren't. They are not. They are rare. I think I got this thing back in Germany when I was still living in Kiel from Ulrich Hoffmann, who's done a ton of things in Forth. And until he brought that up, I don't think I've ever heard about it. I have not seen any other since. This thing is rare.
It was the dream for many of us all around the world. No, we saw the Novix on the magazines, and
Yep.
everybody was, wow, this is the future. This is the CPU, no, on that time.
Yep. Yes, we were, because other stuff wasn't fast. And this thing executed in one CPU operation in one clock cycle at 8 megahertz. An 8286 or 386 at 25 couldn't keep up. I mean, it screamed. It was fast enough that it could generate a regular composite video signal on some of its I/O pins in software. It could generate regular composite video in software. It was fast enough for that. The only limitation was that it didn't have enough space to render a complete screen. It could only do a couple of lines at the top of the screen, but hey, video generated in software. Try to do that at the end of the 80s. Now the idea is to resurrect this and get the simulator working to the point that you can at least command line drive this, because with that, everybody can have one. The simulator, again, it's in 99. It was written in C at the end of the 90s. So it itself looks fairly benign, especially since, as I said earlier, you don't have to do much to simulate this thing. Everything is directly encoded on the CPU, so every instruction tells you exactly what it wants you to do. There are no address translation tables, no variable length instruction words where some operations are 1 byte, others are 4 bytes long, and you have to figure out what you're looking at, multiple step decode. Oh, just think about what that does to performance. So you just have to microcode things. Yeah, then your microcode gets more complicated, your CPU gets more complicated, and oh, did I mention that you have to verify your microcode, which gets expensive. So these old RISC CPUs are very interesting beasts to me. So that's why I would like to get this working again, so that A, I can play with it without having to fear that it signs out on me, A. B, make it so that others can play with it. There is, interestingly enough, on GitHub an implementation of the RTX 2000 CPU, which looks a lot like this thing, but well, it's a little bit more evolved, so it's on my list of things to do to get this working again. Were it not for this old stuff, for these old things, or recently, the ability to run Forth on a Linux platform in form of GForth on Arduino, I probably would have passed this by because it's not old enough, it's not ancient enough, it's not primitive enough. But since I have this old thing, that's what I'm doing. Questions, please.
Yes, I have a question. You said the EEPROM is losing bytes with Edge. You don't have any error correction, ECC, for example, to preserve?
No, this is old school code. Back in the day, error correcting memory was available at the end of the 80s. Error correcting memory got in high-end servers, things that even today cost a boatload of money. These basically consumer grade or hobbyist grade CPUs, they don't have any error correction on the inside. At the end of the 80s, we weren't there yet. We by now have all kinds of internal protection to make sure that things don't go sideways, and even error correcting memory has become cheap and affordable. If you don't want to buy cutting edge, try an older server like, oh good grief, give me something, like an older Spark, a 5440 or something equally big, has error correcting memory. Even an old Ultra 60, by now easily 18 plus years old, will tell you exactly when a memory chip somewhere goes bad, and it will tell you, under Solaris at least, which socket your bad memory is in. Back in the 80s, we didn't have that. Especially hobbyist boards, there is no error correction. So bit flips in older chips are a thing. They happen. The older they are, the more runtime they have on them, the more the more runtime they have, the more. Oh, can I download this?
Mm-hmm.
Nice. Chrome wouldn't let me do this. Let's grab this really quick.
Yeah, Cornelius, I would like to emphasize that it's very important to conserve the binary image that are in the prompts, because on the web you find the source code of CM4, that is the software that runs on the board, but I wasn't able to get to the binaries even with extensive search. So it's very valuable. I wouldn't experiment with the chips with an own programmer or whatever to extract this, but make sure to get the files or the images first and then continue.
Yeah, the idea is, I have a similar other problem here. I have some old Sparks, and these old Sparks, the real-time clocks on these things, they go bad. There's an internal battery in these things. So after a couple of years, they lose their mind realistically. I pulled mine because the idea of having an old battery in an old computer that might start to leak or do other nasty things does not appeal. Right now, since the battery is pin compatible with the same sort of static memory chip that coincidentally this board uses, you can pull the battery chip and put a regular static RAM in there. But the idea is to replace this chip with an EEPROM. Never mind the real-time clock in there. Even a Raspberry Pi pulls time off the web at startup. And let's face it, NTP servers are not rocket science, and neither are the clients. So the idea would be to replace that particular chip with an EEPROM. So before I start messing with this CPU, there's going to be a ton of verification of the programmer before I try anything, including burning my own EEPROMs. Because that's the other thing. If I get a bad part from China hardware, you can buy an EEPROM programmer out there for what, $50? It's USB driven. It has a zero insert force text tool or 3M socket with a little lever on the side that you can get your chips in and out of it easily. It has one of those on there. It has a ton of hardware out there. It's dirt cheap. I think.
Can I just add one thing? Can I just say, I published a computer kit back in the 80s, and there's several versions of it out there, and we have a number of ROMs that are from that period, EEPROMs, 2716s, I think. And we've basically been doing the software preservation on those, and we noticed a strange thing happening with some of the beeping noises. They came out flat because we had frequency tables, and we noticed that there'd been some corruption that had happened. So I can vouch for 35-year-old EEPROMs. You might get 1 or 2 bits lost, and you might get worse, or you might get nothing. You might be perfectly fine. But that is an example of some corruption of a 30-plus-year-old ROM. They do have bit decay in them occasionally.
Yeah, and with this old puppy, I've gotten lucky because it still boots. I can I powered it on. I hooked it up to a Pi with a USB to serial cable on the Pi. You don't attach to the console of a Pi, of course not. No, you get something extra. Then a null modem cable to this thing worked like a charm. Just took me a little bit to figure out what I had to type in for this thing to report. But it came up, it executed commands. I could walk the dictionary. Cool. Oh yeah, the power supply is getting a little bit hot. That runs on two.
Can you just capture the dump then? Write a dump routine and just capture what the dump routine will output. You get a hex dump of the binary.
Yes, that's the other idea, that I basically bring it up long enough with a fan pointed at the power. It's a linear power supply. I built it myself because I didn't get one. Anyway, so yes.
Okay, I have to present the next participant, if you don't mind. Is Holland Forth.
Yeah, one last thing. If you want to know more about this or recommendations, comments, just shove them into the Facebook group or message me on Facebook.
Yep. Thank you.
I'll drop the links to this stuff in there later today.
Okay, great. Thank you.
Thanks.
Thank you very much. Please stop sharing, Cornelius, so we go to the next participant. Is
should be off.
Yep.
Holland Forth from Switzerland, Lucerne. Is Lucerne?
Okay, I'll try to share my screen. Which one? Not these ones now. Do you see this?
Yeah.
A remark from Untitled? Okay, then let's go. So hi and welcome to Holland Forth. It's also in the old ages, this is 89, but I will go to today later. So I'm talking about bringing Forth, refactoring Forth into a way where I could better work with it. And I did it by not using screens nor files, but directly using the words. Programming words in the dictionary. So what did I do here? I had seen Smalltalk and I wanted to have Forth in a browser like Smalltalk. But Forth is not OO, so what is the structure of Forth? And dear old Brody told me in Thinking Forth, he had this nice little piece. And it is possible to chain Forth screens in links. This is not a usual approach. It was a useful approach when you use just one word in a screen. So I actually had a long list of blocks with just one word. And I had got the dictionary. I could edit the dictionary with the screen editor. The second tip, what I needed to know, structure like a book. Screens, as if you have one word per screen, this is true, it's the smallest unit. Lexicons and chapters.
Wolf, I can't see your screen. I see you only talking, but we can't see your screen sharing. Below on the screen, you got a button, a green button, share screen.
Wait a minute. I have
share screen is a green button in my.
No, I have two screens on the Mac.
Okay.
And I've switched the screen.
Right. You still do screen sharing, and then you have to select the appropriate screen.
And it won't give me. Yes, here it is. Okay.
Yeah, now it works.
Thanks.
There it is.
Now I must get you for the picture here. Yes. This away. Yes. And the nice comment of Anton Ertel. Do you see it? Sorry, do you see Anton Ertel's remark? Or don't you?
Yes.
Well, we
yes,
see
we
abstract
do.
introduction
I see your
blocks.
What do you see? Not screens, nor files, but words?
Yeah, right.
And Antonello?
And where is his remark? I don't see it.
It's a remark he did in Forth2020. He was talking about Forth IDEs. And he had said the nice sentence, programmers are pretty married to the editors. So if you tell me to use Holland Forth and it doesn't work with Emacs, I am unlikely to use it. Holland Forth is what I use and what I want to show. So, but I must ask you if you see it. A browser? No?
Yes, we do.
Thank you. And so in the end, I will show that Holland Forth replaces Emacs. So it's doesn't matter. Where are we? Brody's. I mean, this is on my screen, and I hope it's also shared. A piece from Thinking Forth. Uli, ist das auf dem Bild?
Ja, Holland Forth. Na, nee, wir sehen die Webseite.
Thinking Forth nicht?
Nee, die Webseite nur.
Oh, schade, schade. Okay, then I read. Brody had in a part about composition, and there he wrote, structure your application listing like a book, hierarchically. An application may consist of screens, the smallest unit of Forth source. And when he puts one word in a screen, then he actually is right. Then put the screens in lexicons and the lexicons in chapters. That's what I did here. So here is a screen, which is a block with one word, and here a screen editor. And I was a freelancer, and I did one project this way. And the day I had this running and did my daily work, I was finished at noon. So I thought this must be a good idea. Now I have something else to put on the screen, and probably you won't see it. So I must go and this is annoying. So I must go back to screen sharing. Here.
Yeah,
So
now we see the Holland system.
this is the present state of Holland Forth, which shows Holland code. Sorry. The same system as before, but now it is working on its own source. It is Tickle. These are Tickle files and models. The models are the chapters are chapters. And so what can it do? It can go somewhere. It can show what I visited. It can show revisions. It can, let's go here somewhere. And no, let's go to editing. Browsing is also okay. Show from text. I could go in here. No, that's not good. First of all, it's a database. Forth in a database. In the Roland 86, the database is contained in 2 files. Here, the whole program is contained in one real database, which is contained in Tickle, a part of the Tickle distribution, and creates the whole structure that you see here. Unfortunately, I wanted to share, show the program in so I will have to switch to. Oh, hello. Do you see too my whole screen? Uli.
Yep. We see both sides, source code and
also visual code.
Yes.
Okay, thanks. So, and there's one more. So there is a, here are the files from Roland code. And we could go somewhere, for example, set units type. I will go here. And just demonstrate that the files always are fresh, contain the contents of the browser. Little change. No, come on. Load. And now it should be here in visual code. So you see visual code takes care of the files. Going back, it's here. And now please tell me what so I have the full system here. I have several views. The tree view, which can be expanded. I can, that's not good. Browse now, editing. Let's go here, insert, delete. These are always the store text. The nice part of let me go through to a nice place. The nice part is that you have hypertext. If the band page back and so on, I have a history of the last places visited. There is a, what else can I show you? There's a revision log, and the revisions go back till, you can see it here. I'm working on this program since 2011. Always the same database, the if you see here, I can go and look at the words that have been changed at that revision and look up previous versions. So hold on. Whenever I start a new version, it stores the old one, the old page in the dictionary. So I can really, that's my version of GitHub, of Git. Well, I guess I finish now here and wait for your questions.
Very cool, Wolf. So you use this both for automating and standardizing, say generating a text and publication quality, and then databases, if I followed correctly.
No, this is my way. This is my quote unquote replaces this for me. It's a real well. I can do useful things with it. Let me show you this. No, I guess I have it already loaded. Here. Just a little moment. Pity. It takes some time to load again.
Wolf, wir machen jetzt weiter. It's, next is Abraham with Dragon Force.
Yes.
No problem.
Can I quickly ask a question to Wolf before we move on? How do you implement your version control system? Is that a part of TCL, or is it written entirely in Holon?
It's written in Holon. It's just stuff stored in the database.
Okay, and how do you handle that? Is that a cloud-based? Is it going to a website? Do you handle that with PHP in the server, or what?
No, it's in Tickle. It's in a Tickle database.
So it's stored on your local computer's hard disk.
Yes.
Okay, thank you. I was dying to ask you this when I heard last month that you said you've solved the version control problem, and then suddenly you were gone. So I had to wait a month. Yeah, as you know, I'm a Holon fan, so yeah, this looks very good. I think I will steal some ideas from this.
Okay, I hope. Always thought people would steal my Holon 86, the old version from the 80s, 90s, but nobody did.
Yeah.
Perfect. Thank you, Wolf.
Thanks, Wolf.
Very much.
Thank you.
Thank you.
So next one is Abraham.
Okay. Thanks, Peter. I'll get started. Hi, everyone from Atlanta. I'll be presenting on embedded development in Forth, particularly for mobile systems. Here, let me share my screen real quick.
Shit.
Go. Okay. Come on. Okay, can everyone see the Google Slides presentation? Okay, yeah, it's just taking a second to expand for me. Anyway, so Drag and Forth is what I'll be talking about. I've used this for a long time. I think my first experiences with it were in middle school, and I had this $5 Palm, and I wanted to solve the fizz buzz problem just to make sure that my brain was functioning, and then to do other things like I implemented Mastermind and so on. And I knew there was a lot of programming languages that you could use on PalmOS devices, but really that was the simplest to sink my teeth into at the time. Anyway, so I'll go to the next slide. So, why use a dead operating system and a dead platform for development? Well, still with PalmOS devices, there's a lot of tasks that you can do even without a desktop or laptop. I'll stop sharing for a second, come back to this just to show this trio on the right. I'll come back to that in a second. Yeah, so hopefully you can see me now. So this is just on the left is a Trio 755p. It has infrared and as well as Bluetooth and camera and storage and everything. Interestingly enough, what I figured out is with the Bluetooth connection, I can have an internet connection at about 450 kbps, which is slow, but for things like Telnet, SSH, or just looking at simple visualizations or say doing home automation, that's all the speed you need, and the battery life's much better than say the smartphones all of us are using. So even though it's a dead system, it's still valuable. Okay, so I'll go back to the presentation. I just wanted to show that to everyone. And another thing for going back to what Johan mentioned, you can emulate an RPN calculator in there. So if you want to implement algorithms, that's one of many things you can do with it. Anyway, these devices are still very, very common, incredibly inexpensive, and what I'm really interested in doing with them is taking these and putting them to work in Internet of Things contexts. I'm friends with a lot of people with ham radio licenses, and they build this mobile network called APRS, mainly for emergency context, but you can repurpose older computers and even PDAs to send messages over APRS and gather information. So it has just enough power to do that. PalmOS is really lightweight, and it's technically single tasking. There's some multitasking I've seen with particular applications, but it's de facto single tasking. It has network support for TCP/IP, I/O support. It's obviously a GUI, and there's built-in Wi-Fi, Bluetooth, infrared, and serial connections, all that are supported through the system. Because of this, I'd like to use this for real-time data acquisition, some context, communication, like I mentioned, and even visualization. Not, through a Java application or JavaScript in a web browser, but, possibly a native application. I, work in the lab. I'm a graduate student, and knowing whether say a bacterial culture grew up in 6 hours or 12, or knowing the results of the experiments when I'm at home saves a lot of time from day to day. So just getting better at that kind of application would be really useful in my work as well. Anyway, so why use Forth for PalmOS development for this dead platform? Well, there's a lot of options for programming in PalmOS. You can use Lisp. There's LispMe, which is Scheme, but close to Lisp. Python, Pascal, Basic, and then some languages where you'd have to do most of the compiling and development on PC, like C for the most part, and J2ME. Forth has the advantage of, as we all know, a really simple syntax, or a syntax that you can define, a vocabulary that you can define yourself, and speed, but you can also make independent programs with the Forth development systems in PalmOS, which you really can't with, say, Python or Pascal and Palm devices. In addition, both existing systems, Drag and Forth, which is free that's based on SP4, I'll talk about today, and Cordis Forth have PalMOS API integration, and you do all the development on board the device. So I had mentioned Free42. There's an RPN calculator emulator for PalMOS. There's one app that's been developed in Cordis Forth that lets you use the infrared port on a PalMOS device to print to these, which HP calculator fans are probably familiar with, an HP 82248 infrared thermal printer. And the way this app works is it'll take some text that you put in a clipboard. You can adjust it in various ways. It parses the text into the red-eye encoding, and also checks the character set, sets the printing mode, puts that in buffer, then to be sent over infrared, and uses native API calls to control the UART and then set it to the infrared port. And this is just one of many applications that you can still download that was developed with Cordis Forth for the PalMOS platform. Okay, so Dragonforth, then I'll talk about now. This is mainly paraphrased from the manual, but I added some things here. It's ANS compatible. It's based on SP4, but it was also implemented in 68K assembler. Unlike PygMyForth, which I presented in the past, it does both 32-bit and 64-bit arithmetic, and it has floating point support. Although PalMOS is single tasking, Dragonforth supports multitasking. It works on the 68K, really the 68K PalMOS versions from 2, with the original Palm Pilots up through 4. You can build PRC executables rapidly and really easily within Dragonforth, and you can clone the system. There's some 1,000 API calls, error messages, and then a direct interface to the math libraries in PalMOS. These are, typecast, and it supports local variables and dynamic strings. So you can execute within a string that's printed. You can execute particular commands. Okay, so I have one more slide, and then I'll show a quick demo, one of the examples provided, and then point out some of the weaknesses of this system. The development pipeline is, pretty standard for whatever kind of development that you would do on a Palm or elsewhere. You can prepare the code onboard the device in MetalPad, which is a 4K limit, or a doc editor, which would be longer. You edit resources, say dialog boxes, forms, menus, in RSRC edit, which used to be shareware, but of course this is dead, so you can get that for free. You then open up the Dragonforth console, include the source code, as I'll show you in a second, and then you debug in the console, correct errors, maybe go back to the beginning, or just try out your words in the console. And once you've debugged, you compile a PRC. The weaknesses, so far I see of this, is the documentation isn't very thorough. It's really a learn by making mistakes philosophy, I guess, or just there wasn't enough time to have a really comprehensive manual like you see with Cordis Forth. And in addition, as I'll show you in a second, it doesn't seem like the executables work on PalMOS 5, and that's the newer Palm devices on the ARM platform as opposed to 68K that are 300 megahertz as opposed to 33 or 66. Okay, so I'm going to stop sharing this, and then I'll try and just share my whole desktop for a quick demo. Okay. Okay, share screen, show all windows. Okay. Can you see all windows now? Oh, you can. Okay. Okay, great. So this is PalMOS simulator. This is emulating a Trio 650p, which is a smartphone similar to what I showed you. Oops, I do need to unlock. There we go. Oops. Okay. And there's one Dragon compiler and then a console interpreter. I can type in words and then see the built-in words. There's autocomplete you can see here. That's for entering in a string. And I'll go ahead and do two examples. One is just a hello world example. You do string hello and then execute the word included. Okay. And yeah, so you have a form, a menu, and you should see a dialog box, but apparently that's an API call that's prior to Palmas 5, which this is anyway. So that's one issue. Okay, and now I'll just do one more that's a bit more fun than that. Okay, so I'm going to do Conway's Game of Life that they've implemented. And I can also I'll show the one bit of source code after this. So that's a little slow, but always fun. Okay, so I'm just going to show the source code for Hello World if that pops up. Can you see that on the left side of my screen? Excellent. Okay, so this is the Hello World example. The quotes here is just for importing some of the libraries that are in a MemoPad database. It's easy to install. The codes for different resources in the resource file, you know, the about item, main form, and about form that I showed you. One API call, and then when you write the program, the last word that's executed just goes to the main loop of the program. So for the main form, execute that API call on that argument, and then begin. Check to see if a menu event is pressed, like pressing this menu button here, and see if whatever event is equivalent to that. If the event, if its item ID is the about item you picked out, it should drop a dialog box and then get rid of whatever status is put on the stack. And that's really it. All you have to do at the end is call the resources and then use go as your final executable word, and then one more word build for creating an executable. It's really fast and easy. Unfortunately, I don't think these executables work on Palmas 5. I'm trying in the simulator and also on my devices, so I'll see in a few months how Cordis Forth works, and I'll do a presentation on that and hopefully have some more of my own examples. Anyway, so hopefully that's helpful, and let me know if you have any questions.
Yeah, thank you very much.
Abraham, this is a 68K Forth.
Yeah, so it's implemented in Pila, which is a 68K assembler. There's some emulation on Palmas 5, but I think the memory model is different, which is why these PRC files don't work. And then there's also API calls that are different. But for the most part, when you execute within the console, it does work even in a Trio or Tungsten, the newer generation, past about, I think the M505 or 515 was the fastest and newest 68K. And then one other thing about that, so some of you might have seen the AlphaSmart Dana. It's a laptop that runs Palmas. I've modified the resources for the Dragon Forth program so it's widescreen, and you get something like 4.5 times the width, so it's a little easier to see all your code.
Have you compared this Forth to other compilers, to a C compiler or
as far as speed, I think I haven't compared it for speed with C compilers or with Cordis, but I'll put up the links if anyone's interested. I think there was in Cordis Forth some performance benchmarks showing that was much faster than both other purely interpreted or C compiled programs.
It should be very fast for what you show us.
Oh, absolutely.
And you say you've got access to the resources on the Palm computer?
Yeah, so the resource files are just GUI elements that you use in the program, but you also have access to the API, and you could make network calls, so access a TCP/IP stack as well as IR and Bluetooth within the application. Say if you, I don't know, had some text stream at one IP address and you want to interpret the contents of that in the program.
Okay.
Okay, Abraham, I thank you very much for the presentation. It was outstanding. And we chat later on the cafe, on the Forth Cafe.
Oh, definitely.
Okay. Yep. Next one is Joe Connor. Where are you, Joe? Are you there? Can you hear me? You are mute. Joe? Joe, is your presentation ready, or shall we pass to another press? He's mute, Joe. Abraham, can you help me with contact Joe?
Sure, let me go ahead and find Joe in the list of participants. Let's see. Joe Connor asked, okay, I'm asking him to unmute. Let's see if I can. I'll chat with him directly. Please
Hello, Joe, can you hear us? It's no mic, probably.
So, oh, his microphone's not working.
Oh, no microphone, okay. We have, Don is not with us. He was also appointed to talk. We have Ilya for the class, second part of CPU class. And also Bill Ragsdale wanted to show us a Python, pi numbers, or a teeny clever calculation of pi. This is our schedule for today. So everybody can see my screen?
Yes.
Well, everybody knows this is a friendly chat and friendly group. So I am trying to bring together all these genius people from all the world, showing us Forth and what they do. And sometimes I need also help. You can tell me, Peter, what can we do to make the group better? And you can suggest everything. So this is totally open. Abraham, you can also present. It's not only one person work. Everybody can present these meetings. And send us, the page here, meetings. You go to Forth2020. This is Jorge from Brazil helped us create a site. We thank you very much. I think Jorge is with us, and he should talk. I hope he makes a presentation. And you enter here on Zoom meetings, and you find the participants and what are they going to say. I have a salutation part. So we expect participants to tell us about the next presentation. I know the next presentation, but I only publish this when when number 3 is ready. No, I don't want to create expectations. Okay, then what should we do? Joe is with a problem with his mic. Should we let Joe for the next meeting? I don't know. Or later.
Yeah, I mean, we could start with the salutation, the group salutations.
Excellent. Go ahead.
Why not?
Excellent. Go ahead. It's
should I?
Yes, yes.
So,
Yeah, okay.
Okay,
I stop
didn't
here.
expect to skip ahead, but okay. You stop sharing and then let's see where we are. Okay, so right. So this is what I'm doing if I'm not doing Forth and programming and teaching and things like this. Dragon boat racing has something. Dragon has also something to do with Forth, because the swap dragon, of course, is one of our famous pet that describes how stacks will actually work. I summarized my Forth life here. I started in 1982 with a Sinclair ZX81 computer, and it had a Forth on a cassette, audio cassette, and I started to get interested in what's going on. And then I used some systems after that, going with CP/M and PCs and Sun workstations, and lately Macintoshes since 20 years. Also embedded devices, and on that way I've been using lots of Forth systems like F83, LMI Forth. In the beginning we developed Forth 83, which is a 16-bit Forth system for CP/M systems, for Atari, and for PCs. I use that one. I've been involved in using Forth engines like NC4000, RTX 2000, and also things MUPI21 and EP32 lately. In the course of that, I've been starting with having a company of my own with Klaus Schleisig. We developed ocean bottom seismic measurement devices and long-time data recorders. At that time, I did my PhD in safety critical system, worked at Heidelberg printing presses, and in 2008, 13 years by now, I've been teaching at the University of Wedel, FH Wedel, on distributed system machine learning and robotics. And yeah, so I've been using embedded devices and lots of Forth. And in 2016, maybe that's important, along with Andrew Reed, I started the project Forth, the New Synthesis. Andrew Reed suggested this, and so we started to rethink all what we know about Forth, which is quite a lot over the last 25 years, and try to rethink this and disaggregate what we know and then recombine it in an appropriate way. And the outsprings that come from this is pre-Forth, so a Forth that can bootstrap itself, that is very, very simple, and it can do only elementary things. And seed Forth, a token, a Forth system that is just a small core that accepts token-based source code. And you can extend this to also an interactive system. And there are a lot of the techniques are tried out by now. And it's the nice visible feature of seed Forth that it uses emojis on the prompt. So it smiles at you all the time. And it greets you with Spock's greet, live long and prosper. So that's it. I can talk about all these kinds of things. And I just saw 2 slots left, so I wouldn't rush up to be there next time, but obviously at some time next year I can talk about some of the stuff, most likely on the newer stuff, the pre-forth and the seed-forth, for example. You can reach me right at the top corner, uho@xlab.de. Xlab, you probably know, is starting forth when the text interpreter doesn't find a word, for example, the word Xlab. And yeah, so that's my domain. So thank you very much for listening.
Ulrich, excellent. I am so happy you are with us. So next time, probably in December or January, please prepare a talk about every theme you like to present. Is your group or?
Yeah. Okay.
Okay. Thank you, Dr. Tim.
Hi. Can you all hear?
Joe, is you?
Yeah. Can you hear me?
Oh, yeah. Perfect.
Okay. Sorry, I had a problem with my microphone. Okay. I'm going to be sharing my screen in a minute. Okay. Can you see my PowerPoint presentation?
Yes.
Okay, very good. Introduce myself. My name is Joe O'Connor. I'm going to be giving a discussion about the Forth compiler design that I've come up with. A little bit of background. What I primarily use Forth for. I don't really have much of a hardware background. I use Forth primarily as a DSL embedded in a larger application. So I've written the following DSLs: Creole Forth for Delphi Lazarus, Creole Forth for Excel, for JavaScript, Python, Perl, and C#. I have the interpreter, not the compiler for that. And this is the address of my various Forth projects. I have a bunch of others. You may have to hunt around a bit for them. So this is my development methodology. I import whatever version of Creole Forth I have into the application.
Sorry, Joe, sorry, can I ask you to actually run the presentation? Your type is a little small. It makes it quite difficult to read you on the screen.
Okay.
F5.
Okay, F5.
Mm-hmm. Don't sweat too much.
It's not work. Just let me start again.
Just present full screen.
I'm trying to.
It's slideshow. It's in about the middle, 4 from the left on the menu.
Yeah.
Or from the right, sorry.
Okay.
There you go.
Right.
Great. Thank you.
Okay. All right. Start again. What I primarily use Forth for as a DSL embedded in a larger application. These are the versions of Forth that I've written. So this is how I would use it. This is my development methodology. I import it into the application. So if I have a JavaScript application, I reference the JavaScript version of Creole Forth. And then I set up a set of primitives to handle the tasks necessary. So this is a 2-step process. I define a subroutine that follows a specified interfacing convention. It's usually a method that takes a global property structure as an argument and returns nothing. I add a reference to the dictionary with the build primitive method, and then when enough primitives are available, start gathering into high-level definitions. So it's possible to use multiple copies of Creole Forth for the same application, each with a different vocabulary set, which can be useful. In some Forth, instructions can be defined in terms of assembly mnemonics. The primitives defined by Creole Forth play a similar role. So, compiler design, it's a bit unusual. I have no state variable. Compilation starts by pushing the immediate vocabulary onto the vocabulary stack and ends with the popping of this vocabulary. Immediate words are simply words defined in the immediate vocabulary, which the colon compiler will always search first. The interpreter is used by the compiler to handle the compilation. So let me go into what I mean by that. So compilation steps, I have a routine called compile colon. It sets up a new Creole word definition. It populates the name field and fully qualified name field. That's the name field plus the context vocabulary. So if I define it in the primitive hello in the Forth vocabulary, its full name is hello.forth. Using a loop, it does the following step. Looks up each word in the dictionary, builds a triplet with the following information: name with context vocabulary, address, and compilation action. It places a triplet into the pad area. This is a simple list structure. The pad area contents are gone through one at a time and passed on to the interpreter. So words with a comp and PF action are compiled into the parameter field, while immediate words are executed. So exec 0 words, comments are the only case of that now, are handled by moving the input stream pointer. Literals are handled by putting the literal handling code before the literal. So do semi, it pops the vocabulary stack and ends the compilation. Okay. So here are the possible compilation actions, the table. Comp and PF, this is a synonym for comma. It compiles an address into the parameter field. So this is what's going to happen most of the time. An execute compilation action takes an address as a stack argument and executes it. It's used to handle compiling words like compile if, compile then. Exec 0 moves the input stream pointer. It's currently used for comments only, and literal, anything else that could not be found in the dictionary. So this is what pad looks like during compilation. So I have the definition test 1, if hello, else tulip then. So if it takes token 52 and has an execute action. So 52 is pushed onto the stack. It passes execute to the interpreter. Hello, that's token number 5. That's position 5 in the dictionary, or address 5. Has a comp and PF action. 5 is pushed onto the stack, passes comp and PF to the interpreter. Else, token, 53. Okay, I got ahead of myself. Pushes 53 onto the stack, passes execute to the interpreter. Tulip as a token of 6, comp and PF, pushes 6 onto the stack and passes comp and PF to the interpreter. Then 54, execute, pushes 54 onto the stack, passes execute to the interpreter. So, all right, that's very straightforward, a one-to-one mapping of the compiler, but this is what ends up in the compiler. and you can see that it's dramatically different. Okay, this is the compiled definition in the parameter field. So you have 55, and that's 0 branch, and it has an immediate vocabulary. And so compile if with the execute action, it compiled the runtime code for if. So okay. So this is how the compiling words work. They're in the immediate vocabulary. The immediate vocabulary becomes available when the colon compiler pushes it onto the vocabulary stack, and its visibility disappears when it's popped off. Therefore, this vocabulary is already searched first. It won't be prevented from action by a word in another vocabulary with the same name. They're usually defined in terms of 2 primitives. First has a compile time action, and the second one has a runtime action. So if is a primitive defined by compile if. It has code to look up the token of 0 branch in the dictionary and compile it into the parameter field during compilation. 0 branch is a primitive defined by do 0 branch and branches to the address of the following parameter field entry if false. If true, it just increments the parameter field to the next entry to execute. So the advantages of this approach are simplicity. The colon compiler can be defined in about 100 lines of code, depending on the base language. I think that's about how long it is in the JavaScript version. It eliminates the distinction between state smart and state dumb words. So another advantage is code reuse. The compiler is essentially using the interpreter to do its business. So here are my references. Any questions?
Just for clarity, what is an SDL? Just describe that concept a little bit.
The concept of it's a domain-specific language.
Oh, DSL, yes, domain-specific. Okay.
That's how I use Forth generally. I use it as a macro language that sits on top of a regular application. So, for example, suppose I have a web-based C# project. I'll write a bunch of primitives in C# and gather them together, and then run them with the interpreter. Okay. So, or if I have a JavaScript application, I do that. I create some primitives, gather them into high-level definitions. When I have enough of them, I might need like 40 or 50 before I start doing that. So
okay, in Excel specific, what I'm trying to get my head around what you're doing here. What are you trying to achieve in Excel doing this?
What am I trying to achieve? Well, I found it's very helpful in Excel I can set up a bunch of definitions. I can have them execute on a single in a single cell. So I've written a whole slew of applications, and they might do various things. Like, for example, I used one this morning at work. I use it to download one set of definitions. I used to get a set of statistics doing a SQL query, reaching into a SQL Server database and getting some counts. Then another one, I did an FTP task where I downloaded some data, scraped it, and then imported it into the spreadsheet. So okay. Having a DSL on top of VBA is very convenient, I found.
Okay, I'm asking that because what I have done at work, and it's just in VBA, was writing snippets of code to query and get data out of a SQL database. But I could see that one could use something higher as well. Yeah.
Okay. Yeah. Thank you. I can also create like a menu-based system with tabs. It's very easy to set that up, and so I just click on a member of a list and then have it run the code, which I've set up in a cell. So I might say do task 1, do task 2, do task 3 when you click on this.
Okay.
All right. So if you want, here's an example I have for JavaScript. Oops. Trying to get in there. Excuse me.
Joe, we are running out of time today.
I'm sorry. I'll come back later then. Okay.
Yes. No problem. We make another presentation in future. It was excellent. I am very interested to know more about your compiler. It's all okay?
Right.
No problem.
I'm going to stop sharing now.
Thank you very much.
Okay, great.
Thank you, Joe.
Okay, welcome.
Thank you.
Now we have Dr. King wanted to, I don't know if you want to say anything for the next December presentation, Dr. King, if you like.
Yeah, I think I'll just talk a little bit about the Python. I think Python is just a Forth in a disguise. Okay, it's Forth with a completely different syntax, but it is Forth nonetheless. Okay. Yeah. Thank you.
Okay. We have another one, Jan Geronimus. Where are you, Jan?
Hello, can you hear me?
Yes.
Can you hear me? Yes. I have written something in my blog. I also posted it last time on the in the Forth group, and because of that, Peter asked me if I could tell something about that, and I will happy to tell something about it next time. Here are the links to my blog and to the specific post. And what I want to tell is a very short wrap up of what I've posted, but I want to tell about the next part, what I did with Forth and some things, how I used it to control.
Jan, sorry for interruption. Where are you now?
I'm in the Netherlands. Do you have visual or something?
Which city is this?
In Almere. That's a city near Amsterdam. It's when I was born, there was only water, and now they have taken out all the water and there's built a city called Almere. So I'm living 4,000 millimeters below the sea. For 4 meters below the sea, but it's dry here, so that's why.
Very nice.
Yeah.
Okay, in December we expect your presentation.
Okay, thank you. I have some short thing, but I think that can also wait to the Forth Cafe.
Yes, absolutely.
Okay.
We have also Philip Sembrod. From where are you, Philip?
South of Munich, in a small village, well, between Munich and the Alps, Tauting it's called. Hello. Yeah, what do I have to say? So I got to Forth about 31 years ago on the old Commodore 64 platform, when I had put it into my mind to write a small C compiler for the thing, and was looking for a suitable implementation language that would be more powerful than assembler and have compact enough code. Searched around, not surprising to many of you, probably I landed at Forth, Volksforth, or Ultra Forth as it was called back then. And well, finished the compiler almost during my study times, picked it up again very recently, open sourced it in March, I think. And Peter talked me into presenting a little bit about it at the next meeting. And in the course, I've also joined Carsten Strothmann in the effort to maintain Volksforth. So greetings to Uli. Latest exploit.
You did a wonderful presentation on the Eurofort. I was very enthusiastic of seeing your C compiler. So
thank you very much.
Eurofort and your presentation, it was excellent.
Thank you very much. One update from then. In the last few days, I've gotten Volksforth to run on the Commander X16 emulator. So that's a new 8-bit machine in the works out there. Still needs to be polished a little bit, the Forth. The X16 as well, I guess. And I guess that's all from me for today.
Okay, next one, we have Ilya from Moscow has lessons today, second part of the Forth CPU class. We have also Bill from SVFIC, California. I don't know if we have enough time for Bill with the PI numbers, or if we do a short pause, a short break, and after that we go directly to Ilya. Bill and Ilya, you both tell me, please. You are in charge, Bill and Ilya.
Hello, can you hear me?
Yeah.
Do we need some post before I will start? So. Maybe coffee break or someone?
I would make a 5-minute coffee break. Ulrich, what is your opinion?
Coffee is good.
Okay. Coffee is what turns into source code.
Okay, 5 minutes and we go to Ilya, okay?
Okay, I'm here.
Well, is everybody back?
I'm here and I'm ready.
Party time.
I'm here, but I will leave very soon.
I'm here.
Soon. Right.
Ilya, you can call your students and ask for home lesson how it was.
Yes, it's. I really want to hear some feedback from our lessons a month ago. So there are a lot of options to implement FPGA soft core. Oh,
Here is
okay,
my
Cyclone.
Yes, the Cyclone. But I am waiting for the elections in USA. Everybody is talking only of politics. This is the problem. No, my problem is not with the board, it's with my time. I had a lot of work in this couple of weeks. But I am following everything you are explaining me. Wow, it's incredible.
We have 10 years of Ford history. It's not a problem to find a couple of months later.
Yes. Well, when you want to start, it's all with you, Ilya.
Go
Already
ahead.
back.
Okay, I can start.
Can I just say something quickly before you start, Ilya? I just looked at the BBC News website, and apparently Joe Biden has 273. I don't know if you just mentioned that, but so it looks like he's won.
Yeah, I saw that too.
Interesting, thank you.
Just sort of.
Yeah, that's what CNN reports.
Good is what I say. Okay.
73, exactly. At
Which language do we
83.
think Trump codes in? What do we think is Trump's favorite programming language?
There's a thing called Evil VM, which is a flavor of Forth. That might be the one for him. Although I wouldn't call him evil, really.
There are some esoteric languages not entirely politically correct that come to mind.
Oh yes, there are, aren't there? Yes, I remember. I know what you mean.
Oh, come on. He's still trying to master paint by numbers and Scratch.
Yeah, don't knock Scratch. I think it's great for kids. Fantastic way to learn coding, I think.
Yes, it is. That's why he's still working on it. Once he can find the any key.
Ilya,
Okay.
are we okay?
Okay. So I'm going to screen demonstration. Can you see this? Yeah. Okay.
We can.
Perfect. So I will try to show how to create code for softcore newly created. So we have CPU, and of course we want to program it. What we have at the start, we have some Forth code for our CPU. It's Forth indeed, because we have no lowest level machine code. We have Forth primitives like dub, plus, and so on. And we want to implement some kind of these blue things. So we need compiler, we need compiled program, and we need at least 2 ways to use it. We want to use it as a simulator. So we can simulate our very local VHDL, and we need very low code describing content of our CPU memory. This is our first task to test is our code is even working. And maybe we need some kind of memory image to download. It depends on the way we will use our FPGA board. For example, this may be UART. It's very often to meet USB to UART converters, and it's very easy to use with any kind of terminal program. So it's usually it's not a problem to implement UART. And first step in Forth, of course, in Forth. What else? First step in Forth is to describe 2 memory images. This is 1 array to store our code, and 1 array to store our data, but this is not necessary. It may be for simulation. Usually data array is empty and just placeholders for variables. It's not used in real simulation because usually data memory content is initiated by Forth code. And after creating 2 arrays, we can describe a very simple word, placing command to first empty array cell. And briefly, what we need to implement working cross compilator for Forth. First task is very easy. We need to describe primitive words like da, plus, and so on, so on, so on. This is very easy because every word has a corresponding CPU code. Literals it's important to know because of course we don't want to use a special word moving our literal from our host for compiler to our target. So what we want write, for example, 2 plus and 2 and 2 must not be placed on the data stack on our PC. It must be converted to our CPU code. So this task is important enough, and we don't want to write, for example, 2 convert to our target CPU, when another 2 and convert to our target CPU. So this is a question we need to solve. New words, it's colon definition and semicolon. This is very easy. It's just compiling return command. So it's like a primitive word. And we also want to use variables and some kind of control structures. Okay, literals. For a long time, I use a special kind of dispatch number. This is deferred word. It's a long time. This is inside but words running every time after any kind of literal is placed on the top of stack. This is a very simple approach indeed, because when I type 2, it goes to a data stack and dispatch number is executed. By default, it's empty, so no special action is performed with number on the stack. But if I define, for example, some literal word, I can assign this word to dispatch number vector and use it every time I'm typing number for my fault CPU. In addition, I usually use can dispatch flag just for rapidly switch on and off with processing of literals. So previously we defined a very interesting approach when the high bit of command is flag for literal, and another 7 bits are going to the data stack, shifting previous number. So what we need? We need to place a seed, this line, and we need to shift remaining bit groups. So 4 bits and 7, 7, 7, 7. So our code after seed must looks like this. So this is shift, masking, and adding most significant bit, and placing command to the code array. So we must tune dispatching off to prevent processing of all literals typed here. And after this, we need to return dispatching. Okay, this is literals. Startup words. There are snippet of code, so it's starting code. We need to place code to jump forward, because at the start of our CPU will be some defining words for our program. It's not the place where our program will start. It will start at this main label. And we need to place some startup code to jump over our all vocabulary words. Okay, so this is a start definition. This is a place for our future adders. So this is jump command, and this is a seed and place to for future address. Okay, I will show later. So when we execute main, we know where is it. So we're jumping forward to the address known at the main label. And end operation is very easy. It's turning dispatching numbers off and returning to Forth vocabulary. So this is simple enough. Primitives are trivial. It's just to define our new words in a special sun vocabulary. This is not a complete list because I just want to show how it works. Also, I want to show how works variable definition. Variable indeed is a constant in Forth, but it's not a constant in our Forth vocabulary, but it's constant in host Forth, generating literal for Forth CPU. So every time we typing, for example, variable x will be assigned to a special address and performing x, or maybe variable name, will producing literal placing on the data stack on our soft CPU. And this is it's a very simple definition of colon definition and semicolon. It's just producing return address, and you can see this switching between Forth vocabulary and Sun vocabulary. Later, I will explain why I use at least two different approaches from standard Forth. We can see it for now. Dispatch number is a very useful hook. It allows to compile letters to target CPU code. We don't need special kind of processing. We don't need special words. We just may type our Forth code as usual and perform any converting operation as needed. And I found no reasons to use end-style vocabularies. With a static structure, I use Sun vocabulary defined in Forth context, and every time I type Sun, I'm switching to set of words recovering existing definitions. So plus in Forth context will add two numbers on the stack. Plus in Sun context will produce this 48 byte for memory image of soft CPU. This is very easy. Okay, and some words about new Forth I will use to demonstrate how it works. Now I use Qt environment. I use Qt framework to write desktop application, and Qt main application just pass strings to Forth machine, define it as included header file. And what is doing Forth file? It's Q structures for widgets control. So there are some examples to define button and place it to application window. And I asked my daughter to draw some logo for new Forth CPU, and she answers, okay, Pushin is very cute cat, so you can use Pushin for a while preparing logo for your program. Okay, not a problem. Not a problem. Let's run it. Very easy, nothing. And this is code I just showed you. I can load it. Okay. We have button. We have pushing. And we have a very simple example, putting 1 to our LED port, calling pause and putting 2 to our LED port. Okay. Okay. We can see content of our CPU memory image. Indeed, this is Verilog code because I'm writing it. So print code will generate strings. Program will break it and will content of memory of appropriate cell. Okay. Okay. Let's copy it and let's paste it to our existing Forth CPU. Okay, and run. You can see this. We have writing to our LED port. This is our LED. This is writing signal of system bus. And now we have 1 in our LED. And now we have 2. So our memory content is, where is it? Oh, it's not a content of memory. It's just a where is, oh, program. Oops, it's because of not defined. A whole program, almost whole memory content is not defined. Yeah, this is defined cells. So we have memory array defined in our Verilog. It's initiated by our Forth program. Just write it. I can change it. I can change it. Okay. I can restart it and load script again. Okay. Memory content is refreshed. I can rerun. Oops. What happens? Oh, yeah, of course. And now we have 3 numbers wrote to our LED port. That's all. That's very easy. Now we have system level simulation because I don't try to simulate every part of my full CPU step by step. I'm writing Forth code. This is all the compiler. This is all the compiler indeed. I can add my comments, so you can see now it's just no operation. It's call, plus, minus, and output 22. Not too much, of course, but our CPU is very small in reality. But we have full working compiler engine, CPU engine, and we can write Forth code, process it, receive very log initialization file, and use it in our editor. That's all. Thank you.
Wonderful. Incredible.
Great. Mm-hmm.
It's less than 200 lines of code.
Mm-hmm. Yeah, wonderful. Do you share the source code of this at some repository?
Oh, not yet.
Not yet. So it's
Not
in the
yet.
works.
Yes, this is very long history because I tried to use repositories, and almost every time it started from trying to rewrite it and trying to add compatibility and trying to adapt, and all my arguments was just please, let's start to sharing ideas. Let's start to understand what we need. After it, we can implement, we can use another compilers, we can use compatibility, and so on, so on, so on. Please,
Yes,
let's start with understanding idea.
I agree, Ulrich, to Ilya, and I was discussing this with Cecil. He also asked me to share my code, some of my code. And when I share my code, I have found so much trouble because one people is with the Macintosh, the other is with the PC, the other is with Linux, the other is with Windows, the other is with Android, and the other will bring another micro or another question. So it's a word today. And if we share ideas, how to do things, everybody can do that. So I agree completely.
Fair enough. Yeah, just John, I can understand this, and it's easy. And so I've been talking about the ideas. That
I can say now I have about 5,000 lines of code for my Qt application. 5,000 lines of code. It's not too much to write. It's about 100 widget methods implemented. I can place buttons, check boxes. I just write. I just put console to a screen. It's incredibly easy. So it's not Forth converted to some kind of C++ application. This is C++ Qt application controlled by Forth engine.
I have a question, Ilya. My work with a virtual machine, and I already have instructions for this virtual machine. But when I have registers in the stack based CPU. My question is difficult more or complicated the CPU when you have a mixed stack based and register based CPU?
Oh, we did it about 10 years ago because it was a project combining several approaches to code generation. And well, wait, please, I will find these presentations. Yeah, have it. Please wait. Okay, I will share my screen again. I will share my screen. This is two-stage pipeline. Can you see it?
Yes.
And in register CPU, we need to determine operands. for our arithmetic logic unit. And this is complex enough two-stage multiplexing. So first, we need to multiplex all our registers to determine operand 1 and operand 2. And after this, we need to process and to calculate all possible results with two operands. This is very simple pipeline principle. So in a three-stage pipeline, we need to fetch command, to decode, to determine which exact registers will be used as operands, and execute it. And in stack CPU, we don't need to determine by the command read it what registers will be used as operands, because it's always top two numbers on the stack. This is very easy. This is very easy. It is possible. It is possible, but from our experience, the clock speed of the CPU is slightly lower, because we need here we don't need to fetch operands from register file using several fields of our command, because our command will contain information about what exactly registers will be operands for the next command. For the stack, it's useless. It's useless. We know operands are on the top of the stack. So so we don't need this part of time, T1. It's useless.
Okay. I come with this type of CPU when I work with graphics. The first version have a single word for access to register to memory to write bitmap graphics, and then I realized I wasted a register only for working with bitmap graphics, and then make two registers to generally traverse memory for copy or for move memory or for copy memory or for fill memory. And
so you need access to more operands on the stack.
I use two registers and a stack operation, and these two registers facilitate the memory operation, because I load the address in one register and call in every word and different level this register, and when no exist in a stack.
I can say there are always reasons to use different approaches and to add register behavioral to stack CPU. Why not? Slightly lowering clock speed. This may be not a problem if you're relying on hardware acceleration. Okay. So it's always the question. Okay, clock speed and maybe minimum area and maybe minimum program. Of course, it's important, but it's always a question: are we really need this in our project? If you want to say you want to work with your graphics, for example, to your hardware accelerators connected to your CPU, of course, up to you. It's up to you. If you can write for my latest project, I'm starting with software. I'm starting with software and I'm trying to understand what exactly I want to see in my machine code. And for example, if I need 8 cells on the stack, why not? If I want to have additional special register, why not?
Okay.
It's always up to you. It's not because we have a brilliant font language and we must follow it step by step and not to to step aside, for example. This is a very useful approach to provide behavioral you want in your program. Because it's very easy. If you want to add dedicated register, let's add it. Let's add it. If it is helpful, if you can write a working example of code that we'll use this register, it's perfect. This is what ways from my point of view.
I work in different contexts of you. You have in hardware and I in software, but my problem is in interpreter mode, I do graphics pixel by pixel with this approach.
Yes, I think it's very useful to use dedicated register just for graphic supporting. Okay. Of course, you can define coordinates, you can define current color. You can write numbers from the data stack to wet registers, and this is really helpful. I'm agreed, this is really helpful.
Okay.
Stack manipulation, it's not a special magic from Forth. It's just a way to organize data and provide CPU an ability to process it. If you have dedicated registers, if you have dedicated variables in your program, why not? This is a special kind of mixed Forth and register processing system. This is very smart approach, I think.
And now, really, what happened is when I compile to Intel to 86 assembly, I need to simulate the stack, the data stack, and the first compiler, this simulator is full in memory, but an optimized compiler, I make a virtual stack, and try to assign registers to different cells. And when generate code, I do the better use of register in processor. But this is because I not have a stack CPU. And when you say it's more simple, stack CPU, but a register CPU is more complicated in a design level of CPU.
Yes.
Okay.
This is because we have mainstream CPU design from Intel, from AMD, of course. It's the whole world must follow this way.
Okay.
Ilya,
This is what we have in the reality.
Pablo and Ilya, we have Bill Ratsdale. He's going to make a short presentation or short talk. And after that, we continue on the Forth Cafe. No problem.
No problem.
Bill, you are the next one.
Okay, thank you.
I can't hear you, Bill. Is your audio?
There we go. I'll hold the space bar down. Well, good day, good morrow, good evening, gentlemen of the Forth community. Delightful to be here. I'll make an early comment here to say Well, I'll skip the comment. We'll come back on this topic later. So today we're having a very short presentation on a very clever computation of pi. And what I am pointing out is the entire computation of pi is done in 2 lines of code.
We can't hear you anymore, at least as I can't.
Either.
Bill, you've muted yourself.
Unmute.
No, everything's fine.
All right, are we working fine now?
Yes.
Yes.
Yeah.
Very good. So this is a lot of work as a way to compute pi. It uses the arctangent computation. Instead, I would like to find a formula that only uses one variable. My simple mind can only track one variable at a time, and we're going to call that n. Now, n is our desired value for pi, and f of n, the function of n, is the deviation from pi. So if we look down at the bottom, it says if, let's see, we're going to do this iteratively. Each term is the function of the prior term plus the function of n0. So as the function of n0 approaches 0, then n0 itself will approach pi. So we will be using the iterative method. We don't know the value of n to begin with, so we'll just make a guess, and we'll start with the number of 1. Now, the next step is we need to find a function of pi that is 0. So put on your thinking hat. What function of pi is 0? Because as that function of pi approaches 0, we will get our answer. Well, at first I thought of maybe pi squared. Well, that's not 0. And then the log of pi, that's not 0. And e to the pi is certainly not 0. So what about a cyclic function? Well, then I thought about tangent. And if we look at the green arrow at the value of pi, the value for pi, tangent of pi is 0. So this would be a suitable calculation, but the function is not continuous, would be difficult to impossible to compute. So what other function of pi is 0? Aha, the sign. So if the variable is at pi is 0 and the function is continuous. So let's look at geometric example. If we start out with an n0 of 1, the sine of n0 is about 0.84. So we take our n0 and the deviation, add them together to get n1. Now for n1 at about 1.84, the sine of n1 is about 0.9. Add those together, 2 things are happening. We're getting closer to pi, and also our error is diminishing. On this last calculation, if we add n2 and the sine of n2, bingo, we reach pi. So here's how we calculate it. For each iteration, n1 is equal to n0 plus the sine of n0. Well, that looks pretty simple. So in the 4th term expansion, all we had to do is a floating point duplicate, a floating point sine, add the 2 together. We put that into a wrapper. The wrapper is run pi. 1e0 is the floating point 1. We'll iterate 6 times, do the expansion and loop. And here comes, in viewing this as a D chart, we see the simplicity. At the top right, top left, we set up the first value of floating point 1, set up a do loop with the little circle with an X on it. floating dupe, floating sine, floating add. Do it 6 times, out comes pi. And finally, here is our conclusion. The values of n0 at the top left after run pi is 1. To the right of it is 0.84, which is the sine of 1. Add those together. To the second line on the left is 1.84. We got our error term at 0.96. Do that 5 times. The fifth error term, which is the second from the bottom on the right, the error is 0.0000041999. It produces at the bottom left pi to 16 decimal places. And in the blue-green, we see that if we had done one more error term, it would be 1.2 times e to the minus 16, a truly small value. Well, we see at the bottom of the screen, by this expansion, we get sine to 16 decimal places. And from the CPU, likewise, we get 16 decimal places. So I realized, in conclusion, I realized that any calculator that can program sine can also compute pi. So we're kind of cheating because we're using one transcendental function to find another. But in this case, we're interested in exploring the shortcuts. We're finding methods and tricks. In other words, the challenge is how to solve for pi in 2 lines of code. And this method gives clarity, much more clarity than an infinite number series. So do we have any questions briefly? Great, thanks for the use of the hall. I had a great presentation. See you all in a month.
Excellent.
Back to net control.
Thank you.
We have Ceci Bayona. Where are you, Ceci? Are you there?
Sorry, caught me by surprise here. I'm going to be having a presentation next month on Forth in very old hardware. In my case, it's a Motorola 68000 system. I started playing with Forth a long time ago, before any standard existed. So I couldn't even tell you what Forth it was. It was, I guess, Charles Moore Forth. But I moved on to Forth79. I skipped Forth83 and went on to CM Forth. And now that I'm looking at Forth83, I'm kind of sad I missed it because it's really terrific. It's pretty good Forth. So we're gonna doing a demo on Forth on a Motorola CPU, 32-bit machine, and using F83 Forth by Larry and Laxon. And it's pretty good, but the documentation is horrible. That's why I was looking into getting documentation from Dr. Ting, because he has a manual right here that I printed
inside
on
F83.
Forth. So I'm going to be becoming more familiar with it over the next few days, so that the next meeting I can give a couple of demo programs on Forth83 running on a Motorola 68030 CPU. Kind of a very nice board. Unfortunately, the CPU that has all the stuff is not this one, but I'll move Zoom over by the presentation so you can see a picture of the board and picture of the screen running Forth. That's about it.
Excellent. Well, today is everybody had the possibility to show, and we have a Forth Cafe. What is a Forth Cafe? Forth Cafe, everybody can talk, ask, etc. No need to moderate, no need to interrupt you. we can go back to Pablo and Ilya's question, or everybody is free to make questions.
I have a question. I don't have time for this project, but I will show it as an idea for somebody who wants to do something with cheap hardware. I want to try to share my screen. Can I try it? Where is it? This is the screen. Do you see anything?
Mm-hmm. Yep.
Looks fine. Nice and sharp.
Okay. This is some hardware that I did buy some years ago. If it's good, you see some cables and something. That's it's inside is a processor, and you connect it to USB. And it's I did buy this some years ago, and you can use it to analyze digital signals for an Arduino, and it's very easy. It's very cheap. I was very happy with it. Only cost a few euros, a few dollars. And at the same time, I also did buy this. This is what's inside it. A Siglock thing, and it's the nice thing is it has very fast I/O, and inside is an 8051 processor. And I've looked at it. This is what you can do. You get this kind of signals. You can make it when you load the right software in it. But it has a programmable area, 8051 processor. So in theory, it should be possible to run Forth on it. It has a part where there's shared memory. They have a separated data memory and program memory, but there's also inside that processor a shared part. From what I have seen in the documentation. So in theory, it should be possible to run Forth in it and have a very fast I/O possibilities. This is the interior of it, where you can also see the processor. I didn't see any documentation of a Forth system.
This is an 8051 processor.
8051 processor.
Yes, you can use the Forth from Dr. King, the eForth, or you can use. There was a book of Payne. I had a William Payne, the 8051. It was very famous in the 80s, approximately, and I think you can use that Forth.
I didn't. I'll stop sharing my screen now. Let's see if I can find control of my meeting again. Stop sharing the screen. I think it's a very cheap board. It only cost a few euros, and it would be a very interesting project for people to have Forth running on it. Unfortunately, I don't have time for it, but I don't want to think about it. But when you say don't think of the big elephant, it always comes in your mind. So,
Jan, there is also Camel Forth.
Camel Forth, yes.
Yes, it will run.
I've seen it, the Forth of Dr. Ting and Camel Forth. Yes. And I think it's very cheap, and it has a very fast I/O because you can trace also digital signals. And it would be a very interesting board to have Forth running on it. So I don't have intentions to do it, but sometimes in the back of my mind this pops up. So I want to share this idea.
You should give a try with PSOC 3. Is using the same chip, the same microprocessor. Is PSOC 3 or 5 low power is very nice also. C'est from Cypress also.
Sigrock software runs on it. I did buy both boards. I used the one with complete sealed, and it works very nice. But I also have the other one, and I think that would, sometimes when I see it, I think it would be nice if I could have thought on it. I did some investigation, and in theory it should be possible. And I think it would be a very interesting device having Forth running on it because of the fast interactions. So this is my short thing.
We have two versions of eForth for the 8051. The first version was a very generic one, and the second version is fully optimized. So you know, in the second version, the Forth is fully optimized by rewriting every word which is possibly written in assembly. It was. So the version 2 is very fast, very good. So you probably should look at it.
Thank you for the information.
I see we have in the meeting Thomas Goepel. Where are you, Thomas? In Germany or in Brazil?
In Germany.
In Germany. Okay.
You see me? It's the first time using Zoom.
Wow. I found Thomas. I know your project from Hackaday, but I entered with you in touch recently, a couple of days ago.
Yeah.
And we are very happy to have you in the group. And what do you think in December to make a presentation, or in January? When?
Yes, maybe December. So currently I'm quite occupied at work, right? But may find some time to prepare something. So I'm working with these things here. So that's a quite small chip that has just enough RAM and ROM to run a Forth. And interactively. So I squeezed that into compliance, I think. And I've got a small community. So Dr. Ting, I owe him a lot. He made the first work in this direction. And I tried to make that a Forth that everybody can use. So yes, Peter invited me.
You had a wonderful idea, because those boards, I had one of them. They are extremely cheap and very interesting, because some are for a power supply.
So this one, for instance.
I have this one, yes.
This is a small board with LCD display. So it costs almost nothing. It's $2. So it's an LCD. It has one of those well-known controllers for LCD support on it. But in this case, there's already this controller here is a Nov.2020 controller. So this cannot run the Forth. It's this will again be a problem for the MCS51, right? So it could also be run on these things. But I'm working on the STM8 controllers.
And you have built a community for that, Thomas, for those boards?
Yes. I made it. So I started with a small project here for $1 LED display, and this control on it, and tried to bring Dr. Ting's Forth on it. I had to patch it hard. So after some time, people got interested in this project, and the STM8 microcontrollers, also low power. And well, you can actually still get these boards with these controllers, but they are getting more and more rare. and I'm moving to my own hardware. Other people develop their own hardware, but you can buy, for instance, a relay board with 4 relays and RS-485 interface for the Forth. Talking about that.
Now he's gone.
Tom, I think your bandwidth is so low. Turn off your video. It may help when you're talking.
So Thomas, can you provide a link for the board where the sources are provided?
Yes, sure. Yes. I will have to figure out where to type here. So there's a chat, most likely. Yes, there's a chat. So let's try. So this, if you look up on GitHub, this one, you'll find an entry page. And there you'll also find a link to a board that's called XY LPVM, WPM, and that's the board I just showed. Or you will find something that's called STM8 eForth Modbus. This is also nice.